In current electricity, remaining topic we are discussing today, that is resistor. Okay, that what is a resistor? Are you know? Before we want to be learned about the resistor. In previous class, if you take one conductor, that conductor, if it is a good conductor or bad conductor, if you want to be tell about that one, it must be obey four properties. One is resistance, second one is conductance, third one is resistivity or specific resistance, fourth one is conductivity. Okay, these already we learned. Now in that first one, it is resistance. Already about the resistance we learned. What it is? The property which oppose the flow of current in a conductor. Okay, that is called, that property is called resistance. Already we learned. Okay, now the device which oppose the flow of current, the device which oppose the flow of current is known as resistor. Are you understand? Most important. What is a resistor? A device which oppose the flow of current. Okay, the device means a resistor which oppose flow of current is known as resistance. It represented with capital R. Circuit symbol is this one. Okay, circuit symbol is this one. Clear? This is a resistance. Clear na? This is called resistor. Clear? Resistance. Clear? That is represent like this. Now, for that resistors, to know furtherly, we want to learn temperature coefficient of resistance. Temperature coefficient, already in first year we learned. Coefficient already we learned. Coefficient of linear expansion, coefficient of areal expansion, coefficient of cubical expansion. These all are already in heat part we learned. Irrespective of electricity, for resistances, okay, we want to be learned about temperature coefficient of resistance. Okay, in that heat part, what we learned? Alpha equal to, according to heat part, first year heat part, change in length to original length per 1 degree rise in temperature. Per degree rise in temperature. Are you remember this one? Same as it is, but we want to be tell in terms of resistances. That is only. Okay. Here I want to be write temperature coefficient of resistance. It is the ratio of change in resistance. Change in resistance means delta R. Clear? Change in resistance to original resistance at 0 degree centigrade. That is called R naught. How you write? Okay. Per degree, 1 degree rise in temperature. Clear? As per definition, the ratio of change in resistance to original resistance at 0 degree centigrade per 1 degree rise in temperature. This is known as temperature coefficient of resistance. Clear? To explain that, okay, now I want to be take at 0 degrees, the resistance is known as R naught. Here I want to be take, and at T degree centigrade, resistance I want to be take it as RT. Then according to this definition, ratio means it is nothing but like this. Okay, change in resistance, delta R RT minus R naught. Okay, this is called change in resistance. This is resistance at 0 degrees temperature. Clear? Per 1 degree rise in temperature. Clear na? So here alpha equal to RT minus R naught by R naught into temperature. 0 degrees na, so T minus 0, it is nothing but T only, temperature difference. Okay. Now SI unit or unit of alpha is per degree centigrade. It is nothing but degree centigrade inverse or per degree Kelvin or Kelvin inverse. How you tell? No problem. Okay. Unit of alpha is per degree centigrade or degree centigrade inverse, per degree Kelvin or Kelvin inverse. Okay. If you take any metal, for metal, temperature coefficient of resistance value will be always be positive. Always be positive. Clear? For metals, alpha value is positive. If you take insulators, metal means nothing but conductors only. If you take any conductor, it will be positive. Already we know all the material will be splitted as three types: conductors, insulators, semiconductors. Already we know that. So metals are conductors, it is a positive, na? So now insulators and semiconductors. If you take insulators are bad conductors, this is called insulator or bad conductor. Okay. So insulators and semiconductors, the alpha value is negative. Alpha value is negative. Clear? Good. Now, suppose at T1 degree centigrade, the resistance is R1, and T2 degree centigrade, the resistance is R2. In previous, what we learnt? At T degree centigrade, we learnt as RT, and 0 degree centigrade we learnt as R0. Clear? Now, here T1 I want to be take as R1, and T2 I want to be take it as R2. We know that according to that equation, R1 equal to R0 into 1 plus alpha delta T. Don't think more about this equation. Why? Because same as L2 equal to L1 into 1 plus alpha delta T. Already we learned. Same model. R is directly proportional to L. Correct? So instead of this one, here I want to write R1. Instead of initial, here I want to write R0. Okay? At 0 degree centigrade. 1 plus alpha T1 minus 0 means T1. Clear? Similarly, R2 equal to, for this equation, R2 equal to R0 into 1 plus alpha delta alpha T2. Okay, clear? Now, we want to take, this is equation number 1, this is equation number 2. Now, 2 by 1 write down. Now, R2 by R1. So, R0 cancel. So, remaining I want to be take cross multiply. So, R2 into 1 plus alpha T1, R1 into 1 plus alpha T2. Now multiply with this one, R2 plus R2 alpha T1, and multiply with this one, R1 plus R1 alpha T2. Okay. Now this R1 will take this side, R2 minus R1. This one take this side. From that here alpha and here also be alpha. Both are take out common. Then R1 T2 minus R2 T1 into alpha. Now alpha equal to, this one take this side. Then R2 minus R1 by R1 T2 minus R2 T1. Where we are use this one? At two different temperatures, if two resistances are given. At two different temperatures, two resistance values given. Then we want to use this one. Okay, clear now? Most important. Okay, this alpha value is very small for alloy materials. Okay, alloy materials means already we are discussed. Manganese, Constantine, Nicro, like that. Alloy materials are used for standard resistors. Previous already about this one. Previous already we discussed. Clear? Next one. Now next one is Ohm's law. At a constant temperature. Next one is Ohm's law. At a constant temperature, the current flowing through the conductor is directly proportional to potential difference between ends of that same conductor. Okay. Suppose if you take here one conductor like this. Okay. Here potential V1, here potential V2. Difference of this potential means V2 minus V1, or simply we will write as a V. Okay. Like that. At constant temperature, most important, this Ohm's law. Very important. At a constant temperature, the current flowing through conductor is directly proportional to potential difference between ends of the conductor. Between ends of the conductor at constant temperature, current flowing through a conductor is directly proportional to potential difference between ends of the conductor. If I is the current in the conductor, flow through the conductor, and V is the potential difference between the conductor, then V proportional to I, V equal to IR. Most important. Okay, this formula is very important. Okay, here what is R? Proportionality constant. Clear? R is nothing but resistance of a conductor. V proportional to I, remove the proportionality, then we can call it as V equal to IR. Clear? R is called resistance of the conductor. Clear? Now, can you define this resistance from this formula? Very simple. R equal to V by I. V by I means it is the ratio of potential difference across the ends of the conductor to current flowing through the same conductor. Clear? It is the ratio of potential difference across the conductor. Okay? To current flowing through the same conductor. That means R equal to V by I. Clear? This is resistance definition. Clear na? So now we learned resistance definition. What it is? R equal to V by I. Clear? It is the ratio between potential difference across the conductor to current flowing through the same conductor. Clear? Now, what is the unit of resistance? It is nothing but ohm. Clear? This is ohm. Unit of resistance is called ohm. Can you define 1 ohm? Very important definition for one more question. R equal to V by N, V by I. Here V is nothing but 1 and I is nothing but 1. Means 1 volt potential difference is applied across a conductor. Then 1 ampere current will be flow in it. Then the resistance offered by the conductor is known as 1 ohm. Are you understand? The potential difference 1 volt applied across the conductor. Then 1 current ampere will be flow in it. Then the resistance offered by the conductor. The resistance offered by the conductor is known as 1 ohm. Clear? V equal to 1 and I equal to 1. Are you know that? V equal to 1, I equal to 1. Clear? One more time I will discuss the definition, most important. When a potential difference of 1 volt is applied across its ends of a conductor, it produces a current of 1 ampere in it. Then the resistance offered by the conductor, is known as 1 ohm. Clear? Now, up to now we learned about Ohm's law. Okay. Now, which device obeys Ohm's law? Which devices obeys Ohm's law are known as ohmic devices. Clear na? Most important for 2 more question. What is ohmic devices? Draw a graph which are obey the Ohm's law. Which devices obeys the Ohm's law? They will ask questions like this. Clear? What is ohmic devices? Very important. The device which obey Ohm's law. The devices which obey Ohm's law are known as ohmic devices. Ohm's law means V directly proportional to I na? If current is increases, potential difference is also be increase. Means potential difference across the conductor is increases, current is also be increases proportionality. So it shows a straight line passing through origin like that. Clear na? Which are ohmic devices? A galvanometer, ammeter, voltmeter, like that. These are all called ohmic devices. Clear? Second one is non-ohmic devices. What are non-ohmic devices? The devices which doesn't obeys Ohm's law. Which obeys means ohmic devices. Which does not obey or doesn't obey Ohm's law are known as non-ohmic devices. Clear? The devices which does not obeys Ohm's law. The devices which does not obey Ohm's law are known as non-ohmic devices. Does not obey means irrespective of potential, current doesn't increases simultaneously. Clear? Maybe sometimes it will be increased sharply like a diode. Are you know? PN junction diode semiconductors like that. Okay. That's why graph will be shows as like this. Up to a certain voltage, the current doesn't show. After that, the current will increase sharply. Example: semiconductors, diodes, transistors. These are all partially current flow devices. Clear? Semiconductors, diodes, transistors, thermistor. Thermistor are you know? If you increase the temperature, just like as a water heater. Okay, in water heater we are arranged one thermistor. Clear na? Next, vacuum tubes, discharge tubes like that. Clear na? These are all non-ohmic devices. It doesn't obey Ohm's law. Means irrespective of potential, current doesn't increase simultaneously. It will increase maybe sharply or doesn't. Okay. These are all called non-ohmic devices. Clear nama? Ohm's law. What is Ohm's law? At constant temperature, V directly proportional to I. So V proportional to I, V equal to IR. R is called resistance. Proportionality constant, it is called resistance. Clear? Unit of resistance is ohm. Can you define 1 ohm? 1 volt potential difference across the conductor. Then the current flow through is 1 ampere. Then the resistance offered by the conductor is 1 ohm. Clear? Which devices obeys Ohm's law? They are called ohmic device. Graph will be straight line passing through origin. See that? Okay, galvanometer, ammeter, voltmeter like that. These are all called ohmic devices. Non-ohmic devices means the device which doesn't obey Ohm's law, that are called non-ohmic devices. Clear? Semiconductors, diode, transistor, thermistor, vacuum tube, discharge tube like that. Okay? Clear? Next one. And next one is limitations of Ohm's law. What are the limitations of Ohm's law? Most important question for 2 marks. Already we are discussed in the definition. At a constant temperature, V directly proportional to I. Clear? That is only one of the limitations. So it is applicable for conductors at a constant temperature only. At a constant temperature only. Clear? Not applicable for low and high temperatures. It is not applicable for low and high temperature. If temperature varied for a conductor, Ohm's law doesn't obey. Clear? The devices which obey ohmic devices. The devices which doesn't obey Ohm's law, that are called non-ohmic devices. Already understand? So, if constant temperature, it obeys the Ohm's law. That is only the limitation. If the temperature will be varied, means very low or very high temperatures, then Ohm's law doesn't obey. Clear? Ohm's law will be hold for which currents? Steady current. Okay, that's why ohmic devices are follows the steady current. Clear? Non-ohmic devices are variable current. Are you understand? So ohmic devices follows the steady current. Non-ohmic devices follows the variable current. Clear? It holds good if physical conditions remains constant. Remaining other chemical conditions are constant, then only the Ohm's law will obey. Which are not obey? Already we discussed. Semiconductors, diodes, transistors, vacuum tubes, discharge tubes, thermistor, like that. So on. Okay. These are all limitations of Ohm's law. Most important. First one is applicable for constant temperature, conductors at constant temperature, not applicable for very low and high temperature. These 2 points are most important. And Ohm's law hold good only for steady currents. Okay, hold good only if physical conditions remains constant, and not applicable for these semiconductors, diodes, transistors like that. Okay, these are all limitations of Ohm's law. Very important. Clear?